Welcome to Ericsson Educate Tech Travel Game for Mission 4. I'm Dave from Group 10 with my group members Jasper, Nabila, Haika, and Dhiren. First, we talk about modulation. What is modulation? In electronics and telecommunications, modulation is the process of varying one or more properties of a periodic waveform, called the carrier signal, with a separate signal called modulation signal. Simply put, it is a process to make the signal travel further, so we need a carrier to bring the signal for a long distance. There are three types of the analog modulation. First is amplitude modulation, second is frequency modulation, and third is phase modulation. Now let's look at the amplitude modulation. Amplitude modulation can be defined as the type of modulation where the amplitude of the carrier signal is variable with respect to the modulating signal or message signal. Next, we look at frequency modulation. Frequency modulation is the technique of encoding the information on a particular signal by varying the frequency carrier signal with respect to the modulating signal. And the last one is phase modulation. Phase modulation is another type of angle modulation in which the carrier signal is changed according to the amplitude of the message signal.
There are three single shifting keys. To start off with, the first one is amplitude shift keying. Amplitude shift keying is a digital signal that is used to switch the carrier amplitudes. It is commonly known as the on-off keying and interrupted continuous wave. The string of input pulses matches the carrier signal and changes accordingly. As you can see, by using amplitude shift keying in a system, the amplitude of the carrier wave, which is the output carrier signal, is altered according to the modulating signal, which is the input digital system. It is clear that the carrier wave plays an important part in the outcome of the modulating wave in an amplitude shift keying. Next, we have frequency shift keying. Frequency shift keying is a resultant of two amplitude shift keying signals being added together using a summing amplifier. By using frequency shift keying, the frequency modulation of the digital information is transmitted through discrete frequency changes of the carrier signal. As a result, in the end, two different frequencies will be produced, which will then be filtered to determine whether logic 1 or 0 is generated by the logic comparator. Last but not least, we have the phase shift keying. The phase of the carrier is set to 0 degree or 180 degree depending on the digital signal produced, with 0 degree representing 1 and 180 degree representing 0. As a whole, phase shift keying is a digital modulation process which conveys data by changing or modulating the phase of a constant frequency reference signal or carrier wave.
Hi, I'm Jasper. So I'll be talking about the example of PSK. Alright, so the first example of PSK will be the binary phase shift keying called BPSK. It is a more straightforward type of BPSK where binary refers to two phase offsets, which is the logic high and logic low. It can also be defined as 2PSK because it's made up from 2PSK. So we only have 360 degrees of phase to work with, so the maximum difference between logic high and logic low is 180 degrees. So you can see this. The logic low and logic high, the difference between each other is 180 degrees, which is the opposites. Okay. But we do know that by shifting 180 degrees phase is actually equals to inverting the data. So we can think of BPSK is simply inverting the carrier response to one logic state and leaving it alone at another logic state. Okay, so here is an example. So by converting 1 to 0 with the carrier wave, the output waveform will be inverted and leaving others at the other states. Okay, another example is converting 1 to 0, also same. Okay, you can see the output waveform, it is inverted. Okay, you can see here also, from converting 0 to 1, the data also inverted, but leaving others at the same data. Okay, so how to improve or increase the speed in transmitting a signal. Okay, let me introduce you the multi-level phase shift keying. So the example is a QPSK. What is QPSK? QPSK is actually quadrilateral phase shift keying. Okay, QPSK is a modulation scheme that allows one symbol to transfer 2 bits of the data. Okay, compares to BPSK is actually only transfer 1 bits of data. So for QPSK, there are 4 possible 2-bit numbers, which is 00, 01, 10, and 11. And consequently, it needs 4 phase of offsets. So it's starting from 45 degrees, 135 degrees, 225 degrees, and 315 degrees, as the difference between each other is 90 degrees. Compared to PPSK or PSK, the phase change is 180 degrees. Okay, by using MPSK, we can allocate the signals or the symbols by reducing the phase change or increase the number of PSK with 2 power of n. For example, 4 PSK, 8 PSK, or 16 PSK to allocate to track down the symbols. Okay. However, the possibility of error will increase as the symbols will become closer to each other and hard to distinguish. Simple to say, we will hard to determine which symbol is which. You can see here the symbol is 00, 01, 11, 10. So this QPSK constellation view of QPSK. But if you gather more, it will be 01 here, 11 here. So you're getting more closer lah. To solve the problem, the engineers have introduced QAM and APSK, which is a quadrature amplitude modulation and amplitude phase shift keying APSK. So how it works by introducing more phase and more amplitude in different phase. So it is more easier to allocate to detect as it not closer to each other but with different amplitude. So you can see here is 2 amplitudes, 3 amplitudes, also 3 until 5 amplitudes. Okay, for this is APSK amplitude, QAM, both combined with the phase modulations and amplitude modulations. Yeah, so it is easier to detect symbols lah. So and while playing the games, okay, we also read what is baud rate and bit rates. Baud rate is actually defined as the rate of change of signal on the transmission medium after encoding and modulation have occurred. Simple definition is actually the transmission of number of change in signal per seconds. So by using the formula, it's actually bit rate divided by number of bit per baud. It's actually emphasized on the data transmission. And for bit rate, it's defined as the rate of change of digital information of the amount of data being transferred into the audio. Simple definition is the transmission of number of bits per second. Okay, so for formula, it's actually opposite, which is the baud rate multiplied by number of bit bauds. But for this bit rate, it's actually emphasized on the computer efficiency. That's all for our explanations, and thank you. If you do have any problems or any questions, do comment down below the comment, and we will find ways to help you to solve the game.